obviously the pace of development over the past couple of years with, in the tech sector, looking at particularly in the area of connectivity. So having the ability to access data, having ubiquitous data out there that can really be used to leverage and benefit how we operate our vehicles. I agree that the pace of the development has been sometimes very very quick, and it takes some time to adapt and for things to work. But really looking at it from a truck perspective, when we look at integrating systems onto the vehicle, we certainly make sure that whatever it is, whether it's a fuel savings application that informs the driver how well they're driving from a fuel efficiency perspective, or whether it's something like autonomous driving, being able to take your hands off on the steering wheel, we certainly make sure first and foremost that the driver is comfortable with it, because that is where the ultimate acceptance will be had. For us, what we look at is essentially improving the driver experience. So not only adding new technology for technology's sake, but understanding how that works for the driver and understanding how that will benefit the driver. Taking the inspiration truck, for example, being able to relieve the driver some of the monotonous duties of being on highway actually allows them to be more alert and refreshed. On first glance, when you first hear about the system or you first look in the system, you might have some apprehension, but really, speaking from my own experience, getting in the truck, driving a couple of laps, you quickly become pretty comfortable with it. And I think once people get a feel for what the technology actually does and where the benefits are, I think the adoption rate will start to increase. At Daimler, we're very, very much pushing the technology forward. We believe there's a lot of advantages to it, and we really want to accelerate that pace of development because we see the benefits not only in terms of the fuel economy, basically helping to reduce congestion, helping to reduce driver variability, those sorts of things, as well as the enhanced safety. I mean, really, it's a convergence of benefits that technology brings. Passenger car versus trucks, there's a very different sort of business case in mind for trucks where drivers are on the road 11 hours a day or up to 11 hours per day. There's really a good incentive for that. Passenger car, obviously, with having it be a comfort feature, has a sort of a different take on the same technology. So they'll evolve and adapt to their specific market needs. We're looking at technologies today that require that interaction with the infrastructure, require interaction with regulatory agencies and so on. It's not simply now just a component in the truck that makes a little bit of an improvement. So looking at these technologies forward with autonomous driving, for example, having the infrastructure be in line with what those needs are, with having the painted stripes on the road. Looking at the connectivity benefits of big data, having data available to provide real-time traffic and so on. Those sorts of technologies require more than what's just in the truck, and so it's a broader scope that we need to be thinking of and getting people's awareness on. We're actively working now with on the state level and the federal level to raise awareness of these technologies. The whole exercise in Nevada was to kickstart that, to have dialogue with the authorities in the state of Nevada, the Department of Motor Vehicles, and begin that dialogue. And I mean, Nevada took the groundbreaking step to allow the testing of these vehicles on their public roads. We're very proud to be the first truck to be out there to do this testing, and so we're always looking for partners that are able to spearhead these efforts. And working with leaders like the state of Nevada and Daimler really gives us the opportunity as well to define what that will look like in terms of what's needed from a regulatory perspective, what's needed from a liability perspective. For example, we've had discussions with the chief of police on ensuring that the vehicle tracks who's in charge of the vehicle. So is it operating in manual mode? Is it operating in autonomous mode? and understanding how the vehicles are operating. And so it is in that respect. I would say the technology is not the pacing item. It's really getting engagement with the state agencies that will sort of dictate the pace of this development. That's a great question. I think the driver's role in the future, in Daimler's view, will actually be elevated. Essentially, looking at the most sort of monotonous part of driving when you're on highway and cruise control, being able to allow the vehicle to temporarily take over control in those situations really frees up the driver to be more productive. And so one of those things that we expect to see out there is the drivers taking on more of a logistics manager role within the vehicles, being able to plan out more accurately their next load assignments and so on and so forth. But on the flip side, there's still things that the drivers are ultimately responsible for with the vehicles. Looking at the more complex maneuvering that one has to do to get into a loading station or docking station and so on. Those are the sorts of things that will still remain. The drivers will be responsible for doing pre-trip inspection, making sure that the vehicle is operating properly on the road. And in the event that there's a electrical fuse that's blown or a tire that needs to be changed, the driver is still the captain of the vehicle and is ultimately responsible for all those aspects. I think big data plays a role in multiple aspects. I mean, essentially, looking at, I'll take for example, on one hand, on the infrastructure, you mentioned it before that. Congestion is a big issue, and infrastructure is a bottleneck in that area. So using technology and using data to provide more real-time traffic information to get more routing and loading assignments that will avoid some of those traffic issues. Getting upfront awareness of thunderstorms in certain areas to avoid. All those things are sort of improving at an incremental pace, but I believe even in the future, using big data will allow us to further fine-tune how the vehicles will be driven and which routes they take. Regarding the driver environment, regarding the driver health, monitoring the driver's safety, those sorts of things, I think that also plays a really important role in terms of ensuring that the driver is in good physical condition and good condition for driving. But then also through automation, relieve the driver some of that cognitive workload that we've talked about before, and kind of take that sort of the stress and monotony out of the driving to basically leave them more alert. When you think about the vehicle network, you have in every second thousands of messages about how the vehicle is being operated, what speeds are they at, what torque are they at, how are the brakes being used, and all that information is used to operate the vehicle in an efficient way. What we're starting to learn now is if we take that data and we start analyzing it, storing it on board to see, okay, how are the brakes being used, and sort of calculate when we think the brakes need to be replaced. Looking at the engine speed and torque situations as they drive along the road, we can also predict when oil changes will need to take place. Having sensors in the tires, being able to measure the tire pressure and the tire temperature. Essentially, we could put an odometer, as it were, onto each tire, and so we'd be able to better fine-tune maintenance practices as well. And so I think we're still really at the tip of the iceberg of what's possible. You start seeing inroads in those developments, but really I think we've only tapped the tip of the iceberg of what's out there with data. So I'd like to take a step back and maybe sort of reflect a little bit on the long view. We talk about the tech industry, which is extremely fast paced, and we're talking months where there's new developments and new cycles. And we're also in an automotive world where development cycles do take a little bit longer. And if I think about safety systems like we have had in the past, let's take ABS, for example. Daimler came out with the world premiere of ABS in passenger cars in 1978, and it wasn't until well over 20 years later when finally that technology became more or less standard in all vehicles, cars and trucks. And then if you think about the fleet turnover, that's probably another 10 years. And so when you look at deploying that technology, you do look at in the case of ABS, you do see a sort of 20 to 30 year time span before that full impact is felt. And certainly the technological development is one part of it, but that's really at the beginning end. And so the rollout is really what's key. And I think to some extent that's what's going to happen in the future as well with autonomous vehicles and so on. We'll be out with that technologically speaking pretty quick. But when you think about what it takes once you initiate or once you launch a product, it takes a few years before that becomes fully a standard, and then it takes another several years before it becomes in the overall fleet. And so when we introduce something like the highway pilot, it's still going to take another 10 or 15 years for that to play its full effect and to see the full benefits. I had the privilege to oversee the Super Truck program, which dealt exactly with that topic about how the vehicle can look at in the future. And essentially, the powertrain is a big part, not only the engine but axles and transmissions. Getting the matching of those systems to work properly, you have to have the right axle with the right axle ratios to match with the right transmission and to the engine ratings as well. So it's really an overall systems approach. Aerodynamics as well. There is that tension between the design groups for aerodynamics and styling. I think at the end of the day, and when you put pen to paper, it is possible to achieve both aims, and it takes a little bit of compromise on either end. But taking a look at what the Super Truck looks like and having some fuel economy development programs such as that gives us a good glimpse as to what comes down the line. And I think there's a mix of some architectural changes to the vehicle, and then a mix of some minor changes as well that'll all add up. But one thing certain is that it's going to take a vehicle level approach to get future gains in the future. It's not really a puzzle piece where you can take one system and add some efficiency and get fuel economy. We're going to have to integrate all these things together to make further gains. So the interior of the truck is going to have to be designed to attract that next generation of drivers, and those drivers will have certainly a different set of expectations on what the vehicle is able to provide in terms of comfort and drivability and so on. And so what you're seeing in the greater degree of connectivity and the ability to have internet and those things on board, entertainment systems and so on for the sleeper area, but also when you're driving to provide input. For example, how we have a system called Eco Driver Feedback, which calculates the how fuel efficient the driver is driving, and you create that into sort of a game that the drivers will be able to work on. So I think the things that we want to look at is to ensure that we don't distract the driver with too much information and provide things that maybe is not critical to their driving, but only present what's relevant at which time for the driver to support their work role. I think in the short and medium term, diesel's still gonna be the predominant fuel, and I think even looking out to maybe in the next 20 or 30 years, even that you'll see some inroads possibly with natural gas and those sorts of things, but I think diesel is still going to be the main player. What may change is the composition of the diesel. It may come from more biosources rather than petroleum. I'm frankly not too much the expert in that area, but I think the diesel power plant that we have today we'll see in the coming years. We've done some let's say hand calculations about looking at electric drive vehicles. That's something that's really being pushed in the passenger car area, and today there's certainly a lot of challenges to bringing that on board. Looking at current technologies or what they even project out the next 20 or 30 years, the amount of batteries you'd need to drive a vehicle for 600 miles a day at 80,000 pounds, you frankly wouldn't have room for freight anymore. So that avenue is really, really closed off. But yeah, in a 50-year time frame, it's really kind of hard to see how that would play out. But my guess is that there would still be a fair amount of diesel at play. That topic actually, I'm pretty excited to talk about, because you do see the pace of change. Also, more in recent years, you see the acceleration of some of those technologies improving quite drastically. I mean, when you look at, for example, a camera system that we've got on board now, the camera system is able to measure the situation 100 times every second. The human eye can only do that 30 times a second. So literally, that camera can see quicker than the human eye. These camera systems are also, for example, can have a better sense of depth perception than the human eye as well. They can estimate something out 50 or 60 feet with greater precision than a human eye can. And so the increasing speed and the increasing capabilities means that these systems actually have the potential to be better than the best driver. And I think that's ultimately what the goal is we want to improve safety to that point, such that our vision in the future is to have accident-free driving. And I mean, until you reach that point, there's always going to be work for engineers to do. But part of that will be the technology, and then the second part is actually getting it out deployed. And I think once this technology becomes the prevailing technology out there, then you'll start to see a drastic amount of improvements there. Fuel economy is the same thing. Looking at the connectivity, the wireless information, we're able to explore things that we really haven't explored up until now. Looking at automated driving, smoothing out the traffic flows. We've even talked about options like platooning, which can leverage fuel economy gains for multiple vehicles driving in formation. And so these ideas start opening up once you realize what the underlying technologies can provide and achieve.